those of you that watched the last video that it didn't make a whole lot of sense, what we're going to do is we're going to do one where you have exact solutions. Our equation was x squared plus 10x plus 24. Okay? We're going to check the table, and then we're going to transfer this table over to our page. Go back right here. Now, Emily, what was our vertex? What did you find as the vertex for number 5? -5, -1. So here, I'm going to go -6, -7, -8, -9, and go down. Now, here's how we found it. Right here, if you look at this table, you can easily see that the y values right here are symmetrical on either side of this axis of symmetry. All right, so when I go back over here, -9, what's the value that goes with -9? Help me out. 15. We have -8, 8, -7, 3, -6. So now that we have those, I can start listing the other ones. We have a 0, we have a 3, we have an 8, and we have a 15. Now, we're not going to be able to plot all of these, but we should be able, on this particular graph, to graph all of these points right here. Now, the last problem, everybody, we did not have exact zeros. I mean, they were approximate values, but we didn't have perfect zeros. Here, look, we have 2 of them. We have one right here, and we have one right here. So if we graph this, we have -8, +8 right up here. We've got -7, +3, -6, 0. That's one of our answers. -5, -1, -4, 0. That's another answer. -3, 3. And finally, -2a. This line right here represents the axis of symmetry. Notice a lot of you did a really good job of making a nice, precise graph. Probably more precise than mine. Pencil's a little bit easier to use. All right, so there's your graph. Now, this time, I didn't write the words between. I didn't write the words between anything because the 0 was exactly located right here and right here. So our two answers are -6, comma, -4. You could say x equals -6 and x equals -4. There's no fractions here, right? Integers. They're integers right here. That's an integer at -60. That's an integer at -40. So what did I not have to worry about? I didn't have to worry about writing the word between. The last problem, our roots were not perfectly, say, at a -4 or at a 1. They were between 0 and a 1 and between -4 and -3. We were estimating. Okay? This time we didn't have to estimate because they were perfectly at these 2 points. All right, let's look at problem number 6, this last problem. We need to locate A, B, and C. A is 2, B is -1, C is -6. If I wanted to draw in my axis of symmetry, we're going to do -b over 2a, which gives us a 1 over 2 times 2, which is 4. Got a 1/4 as an axis of symmetry. Right here is a half. Right here is a half of a half, which is a 4th. So do your best to draw in a 4th as your axis of symmetry. You're going to be pretty precise there. Okay? That's not precise. That's not bad. Okay, right there. There's your axis of symmetry, which means all the points would be symmetrical across this line. Okay? All right. So, 1, 2, 3, 4, 5. I'm going to write 1/4. And if you type this into the graphing calculator and find the ordered pair that goes with this, or if you took 1/4 and plugged it in, I'm just letting you know you would get negative 6.125, which is negative 6 and an 8. It's kind of hard to plot. Negative 1, negative 2, negative 4, negative 5, negative 6. Negative 6 and an 8 we're just going to estimate to be right about here. That's our vertex. All the other ordered pairs, I'm not going to make you guys make it too difficult. We're just going to do the integers. Okay? So what's the next biggest or next smallest number right here? We're going to say the next one is a 1. That's a 0. That's a negative 1, negative 2, negative 3. Then we'll say 1, 2, 3, and a 4. So if you guys would please, and your calculators, hit y equals, type that in, and just check your table, and we'll just fill in the table with other pairs that we can possibly plot. So we have 2x squared, is it minus x? Yeah. Minus 6 or plus 6? Minus 6, okay. All right, and I said I wanted you guys to go start at what, negative 3? I'll scroll down here so we can look. Oh. All right. Negative 3 is with a 15. Okay. So we can't really plot that one. Okay, what's negative 2 at? Negative 2, 4? What about negative 1? Negative 3, 0 should be at negative 6. 1 is at what? Negative 5. 2, 0. 3, 9, and 4, 22. So obviously, we're not going to be able to plot all these. All right, we're going to basically be able to plot from here to right here. That's it. These are the only ordered pairs that we can plot, and these y values are not symmetrical. Okay, because we didn't break things down into fourths. Okay, if we broke things down into fourths, you'd be able to see that they are symmetrical. But we're not, so they're too hard to plot. So plot a negative 1. Negative 3 right here. Plot a 0, negative 6 right there. 1, negative 5, and 2, 0. We are going to have one exact solution right as an integer, and we're going to have basically an approximate solution, which is going to land us between two integers. So let's think about where they will be between. Does everybody see that a 0 for your y values would probably be between a 4 and a negative 3? That's where your 0 for your y values would be. Which means one of our answers has to be between which two integers? Between a negative 2 and a negative 1. So we're right. Between a negative 2 and negative 1. There's another one where the y value is perfectly equal to 0. This is our exact answer. Where's our exact answer located? Where x is equal at it, exactly at a 2. So you could say it's right here, Mr. Namood, where x is equal to a 2. And the other one is what? Between a negative 2 and a negative 1. So when you draw this graph, do your best to draw an accurate graph that goes perfectly up through 2, 0. And this other one is going to go down between a negative 2 and a negative 1 until it reaches and it bottoms out. How do I know that I don't go past this negative 2? Because technically, where's the ordered pair? At a negative 2 and a 4. So negative 2. 1, 2, 3. The next ordered pair would be somewhere up there if we have room to plot. Okay? So we know our other 0, everybody, is located right somewhere in here. And the other one is right there. So this answer was kind of tricky because we had an approximate value and we had an exact value. Now, there is a formula that we will review to make sure you guys know how to use where you can find the exact solutions every time. Whether it's perfectly at an integer or not an integer, just at a rational or sometimes irrational.